most people don't know what current AI can and cannot do. It's not just like this mythical black box that they just have to be scared of. We are all centaurs already. We live most of our lives on digital technology connected with other human beings. We are part of some weird form of a hive mind, and we are all kind of cyborgs.
And it's like, yay, we invented fire. Oh, guess what? One of the greatest things in the world. It also is one of the most destructive things in the world.
More people are killed by vending machines than GPT-4.
Driverless car crashed and killed somebody. Take them all off the roads. They are absolutely not to be allowed. Well, wait a minute. Compared to what? Do you know how many crashes killed people with a human behind the wheel?
Would you trust a government regulator to test software for bugs before you install it on your computer?
It's like Big Brother is actually little brother who's not so terribly bright.
We're relitigating the same arguments in like a 10-year cycle, and it feels like we're stuck in Groundhog Day.
Well, hello, everybody. It's Jim O'Shaughnessy with another Infinite Loops, one of my favorite people. And how many times have you been on, Rohit? 2, 3?
Not enough.
Good answer. My guest today, returning, is Rohit Krishnan, the proprietor of the Strange Loop Canon Substack. But today we're going to talk about a great book that he wrote called Building God, Demystifying AI for Decision Makers. So, right, like AI is filled, man, they think Wall Street and other professions are just built around buzzwords. I mean, like, foundational concepts of AI are, neural networks, long, short-term memory, scan models, deep fakes, maximizing objective functions, lions and tigers and bears. Oh my. So I'm going to give you a lot of time to do this first question too. Can you try to simplify and demystify AI for our highly intelligent but still needing to know listeners and viewers what's going on in AI? And welcome.
Thank you very much. Thank you for having me back. As always, it's a pleasure to talk. And as always, you start up with a real softball. So I appreciate that.
Sure.
So, two thoughts. I ended up writing the book accidentally because I ended up writing it to explain to someone after having a bunch of similar conversations about what they actually ought to know. And two things struck me. Number one is that most people don't know what current AI can and cannot do. And that is a giant question. And number two, most people don't know how to think about the fact that what it will be able to do, at least in the future. So the name of the book ended up being a nod to the usual discourse that exists, fear and loathing and amazement at the fact that we are ending up building God. So to me, like, the core question that I was kind of struggling with is when I was talking to folks across multiple industries, whether it's in biotech or health or insurance or financial services, how do you explain to people where they might actually be able to use AI in order to kind of do their jobs better? And what do they need to know about the history and where it came from so that it's not just like this mythical black box that they just have to be scared of or don't understand and input all of their hopes and fears and project all of the worries onto. And same holds for policymakers, right? I mean, if you hear the discourse that actually exists, a lot of it is fairly apocalyptic or at least extremely high level. That starts at the point of, they can reason, they're getting better, therefore they will get better at everything, therefore we're all going to die, or some version thereof, which exists in multiple large parts. So my contention is, as sort of highly simplifying, is something as follows, that we have been exploring how to encode information in various different formats through neural nets and its variants before and after for a fairly long time. It turns out that if you do arrange them in a particular form, in a particular series, and if you do matrix multiplication in a particular series, along with a couple of other neat little tricks, you can encode an enormously large amount of information in a substantially small corpus. And not just that, it kind of preserves the internal structure. What is the benefit of that? It means for the first time in human history, we have computers that can actually talk back to us based on what we actually trained it on. Now, whole list of questions pop out of that. How well does it understand? Does the fact that it is able to talk back to us mean that it actually can grok the meaning of the things that we are asking? How well it does it do out of distribution? A lot of these questions are highly unclear, but the fact of the matter is that at least as far as we know today, what we train it on is actually what it is best at regurgitating back to us. But this also means that based on this, plus a huge amount of research that is ongoing at the very moment, including a list of things that I say, like, whether it's multimodality, whether it's on better memory, whether it's on, differentiated structures, not just transformers going to state space, we can actually build far better models soon, which will be able to understand a lot more about the world that we live in. If you put it together, if you're a decision maker, your decisions come down to something like, is one of these AIs going to come and replace a large number of my workers, either because you're worried for your job or because you want to actually increase your margin if you're a business owner? And the answer to either of those questions is actually yes, but not exactly in the way that you're thinking. Because where the places that it starts is the places where the training data is most easily available, where reasoning is not hyper complex, and you can actually replace part of the value chain relatively easily without replacing parts of the value chain on either end. You can replace the creation of an image, but if you want to actually put that image into a whole series of workflow to create like a frame of a movie at the end, this turns out to be a little bit more complicated. We'll get there as well, but that is the progression that I'm trying to imagine. And in trying to place it in that kind of a format, the hope is that you see that this is the continuation of a long series of innovations that we have been making since we going back to the original discovery of algebra, and therefore contextualized to say that, like, even though that sufficient degrees of change in scale creates degrees of change in scope, there are specific areas where you might be able to apply it and actually create substantial change. Hopefully that kind of succinctly covered it. Not quite succinctly, but
you did a much better job than I was expecting. Man, are you a large language model yourself, Rohit?
I feel like it sometimes, man. There are times when I speak and the tokens just come out,
All right. So up next, we have a question from a large language model itself. I asked a large language model what it would like to ask you. And so I'm going to read it to you and hopefully have you answer it. This large language model says, and he's speaking to you, or it is speaking to you, in your description of AI as a fuzzy processor, you acknowledge a level of unpredictability in AI behavior. How would you balance the need for predictable AI systems with the inherent uncertainty of their fuzzy outputs in critical applications?
Extremely important question. Thank you, unnamed AI, for reading the book. What's funny about this is, like, we spent a very long time in software specifically, where we tried to codify ways of working so that we don't have to redo work on top of it. I have this thesis that software programs are one of the most complicated human achievements that we have ever made. Because if you think about the dependency graph of anything that we normally use, like Zoom, for example, it is much longer than almost the dependency graph of anything else that we have created in the world. Anything physical, for example. We are all depending. It's like the old XKCD cartoon of a small OSS project, except that it's not one small OSS project. It's like 1,500 of them, and small changes in that can destroy everything. The reason that exists is because software, once written, is highly deterministic, and barring the occasional bit flips, actually does what it's supposed to do. However, that creates a problem, because that it only does what it's supposed to do if you know what to ask it, right? Like, if you ask it highly specifically, it does what you want it to, but otherwise it can't. And hence, the need for programmers who actually know how to ask it questions in highly structured formats. For the first time, now that we have created something that can actually talk back to us in our own language, or convert our vague extrapolations and hopes and dreams into something slightly more legible and structured, we have something that I call a fuzzy processor, which is that unlike the processes that we created, which are highly deterministic mathematical operations, these deterministic mathematical operations somehow manage to convert unstructured information to structured information and structured into unstructured. But the drawback of a fuzzy processor, and you are one and I am one, is the fact that if you ask us to do the same thing twice, the chances that we will do it exactly the same this way an old-fashioned robot would have done it is not very high. Because, this is why if you think about the professions with the most drudgery, these are the ones where everyone is treated like a cog in a wheel, an assembly line, and marks, and yada, 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 because it is what is alienating us from our very own humanity, right? You're kind of picking and packing the same thing repeatedly. You're like a machine. You're not using your inherent human tendencies. So with an LLM, the fact that it's a fuzzy processor means that you can now use it in a lot of different places where you could not have used an AI or any kind of software before, because it can effectively be a replacement for parts of sort of different jobs that people might actually be doing. However, the problem is that if you or I, as fuzzy processors, are used in those places, we can be tested, we can be evaluated. Like, if I'm hiring someone for a job, I know that they're not perfectly predictable. However, I can talk to them and kind of get a sense of how unpredictable they are and like how they would actually deal with different situations and monitor those in different ways and ask for, previous employers or references or interview them and create basically this like cone of uncertainty, if you will. Like I can bound it. So I know that they're not completely crazy. I know that they will do some things, but it'll be within the bound of error. So with LLMs and fuzzy processors, we're at the early stages with that, right? I mean, we have this, but the inherent fuzziness is problematic only because you cannot depend on when and how it is actually likely to be fuzzy, that it might end up going in any kind of random direction. So for us to be able to use it in any actual real life situation, especially in critical applications, we would need to have a whole lot more confidence in how precisely it works. We would need to like not its in the internals of like, specific nodes and weights and stuff like that. We already know it, but it's slightly unhelpful. It's like doing, I don't know, neuroscience to predict behaviorism. I don't think it is hugely valuable in and of itself. However, we do need to bound its behavior in some sense so that we know it cannot go completely off the rails when you're trying to use it. Even with that, I mean, we are speaking what after the latest Boeing disaster, not that long after. So when you talk about complex systems where large number of parts actually interact with each other, there are the possibility of something going wrong always exists. So the way we solve it in real life is by having stringent QA and multiple checks and huge levels of evaluations and large amounts of redundancies. And the exact same principle applies for fuzzy processors as well, where the only way to make a fuzzy processor function in a critical system is by having large number of evaluations so that you can bound it, creating enough structure around it so that even if it does something weird or crazy, you can actually, cut off those particular probability branches of the tree and you can kind of direct it towards something, and having large amount of redundancies so that you can actually ensure that the output that is coming from it is effectively usable, so that even if it does something crazy or stupid, the errors are not continuously compounded over a period of time. It's like that. I don't know whether this is apocryphal, but I remember hearing this story about Elon where they were trying to send computers up along with the Starlink satellites, and obviously, like radiation shielded computers are very heavy and highly expensive, and radiation shielding is important because bit flips are more common when there is higher levels of radiation that actually hits once they're above the atmosphere. And I think his solution, or the solution as one of his engineers in that particular apocryphal story, was to send 3 and they would just vote because chances of all 3 getting hit simultaneously are much lower. And that's a way that we normally, that's a way to use redundancy to solve for unpredictability. And I feel like a similar kind of thesis has to exist with respect to sort of LLMs as well. And a corollary of this is that it has to be local and it has to be fast, because otherwise you can't do thousands of recurrent API calls very easily unless you can ensure that they will run ridiculously fast. And you do need checks and balances. I know at least the last point is something you're highly sympathetic to, but happens to be the truth.
Indeed. And again, I asked this particular large language model to make your argument for you. And you actually just hit on several of the things that your AI counterpart came up with. He did get a bit, it did get a bit cheeky though, when he suggested that you, Rohit, as a human, might be seeing fuzzy from your perspective. Maybe you're the fuzzy one, said the large language model. And I went, oh,
That
snap.
that is awesome. I mean, it's possible, right? Like pareidolia is like a known fault of us humans. So it makes sense that we are the ones who are seeing it fuzzy. And it makes also sense for it to think that just because, like, look, ultimately, if you kind of boil it down, they are doing the deterministic number-based matrix multiplications and tokens, which are also numbers, which means that the output there cannot be highly probabilistic. It is actually deterministic. It seems like it is probabilistic to us or fuzzy to us because it doesn't conform to the same notions of how we might actually go ahead and solve it, which also makes sense because there is no logical reason to believe that, you know, a large language model trained on an enormous corpus of internet, you know, um,
The
exhaust.
pile.
Yeah.
Yeah.
Yeah. There's no reason to believe that that will have the same world model sitting inside it as we do, even if we were solely autoregressive large language models who behaved in a similar fashion. So maybe they are just like us, just from, it's like Marvel Universe. They might be from a different multiverse, which is a decent way to think about it, actually.
That's so funny. I went down that rabbit hole as well, and it is a lot of fun, and it generates a lot of great, in my opinion, sci-fi novels that actually don't have to be dystopic. There's a lot of them that turn out to being pretty cool. We programmed in this concept of patterns, which are primitives, basically.
Yep.
What large language model and other multimodal developers call, the AI itself in its on-tuned, on-formatted form, they call them primitives.
Right.
And that goes back to patterns, which are kind of the basic building blocks, right? And I had read something by Howard Bloom where he's saying, what's really interesting about patterns is that, deterministic, precise mathematical principles, sort of the heart of deterministic thought, can suddenly spring forth something that is much more complicated, much more bounded by probabilistic thought and outcomes. What do you think about that?
I think I've written about a couple of these things before, which is that at a sufficient degree of complexity, highly deterministic systems can also show highly indeterministic outcomes. I am by no means the first person, right? I mean, this is it's a common trope in pretty much anything to do with chaos theory or like even things like, sand piles and grains at the point of avalanche and cascade. And there's a bunch of these questions which are, in my opinion, like more feasible to see happen than to predict how it will happen because prediction requires you to effectively run the experiment, so to speak. And I'm fascinated by that. So I think like, in some sense, we in like normal conversations quite often complicate indeterministic with random, and they're two or unpredictable with random, and they're two different kind of processes. I mean, like there's this the common argument that people make against things like free will is like, everything is a physical phenomena. Physical phenomena, given a sufficiently powerful computer, might actually be able to get simulated, and therefore you might be able to predict it. And it's one of those things when, logically it might hold true if and only if the computer that is predicting it did not need to actually run the simulation in order to predict it. And if it did, then from the perspective of the people being simulated, us in this instance, the outcome will still end up looking indeterministic, right? Unpredictable, even though like theoretically everything was as preordained. I know this has kind of vexed and driven more people mad than me, but I think there is a core kernel of truth here that just because you can't create beautiful analog equations to predict the behavior of a particular piece of software, physical phenomena, whatever, does not mean that that is random. It just means that at a certain degree of complexity, there are way more permutations and combinations of how things can go wrong than there's feasible for us to, I don't know, conceivably identify. And as we said in the previous, like the only way to solve it is by having sufficient amount of QA and redundancy and kind of bound the system so that you can actually be relatively sure that it does what you want it to do. I mean, stock markets are a perfect example of this, right? I mean, the flash crash is my favorite example of this. Like, you know, it's not an intended behavior of the system, but it is one chaotic outcome that could have happened. And how do you stop it? You don't stop it by like stopping each individual trade or analyzing each one. You stop it at the macro level, saying like, if it falls a little this much, we cut it off, which is a macro behavior that then controls the micro behavior of each individual algo, which kind of takes that into account. And even if it does hit, we mean that the worst case scenario is bounded.
And you also cover that in your book because you posit that we could have a so-called flash crash of AI. And why don't you tell our listeners a little bit about your solution for that?
Yeah, I mean, I think the reason I kind of got to that was because for a few months I've been thinking about what is the worst case scenario. Do you know what I mean? Like, I mean, the general discourse around the worst case scenarios from AI are, to me, seem like positing too much, or at least kind of giving the frame of the question implies the answer, as opposed to kind of the logic that underlies the question implying the answer. And to me, like the one part where I do see a problem is that suppose we do create AI that is fantastic and it's relatively steerable the way we are saying, and we bound it and it actually works inside any of the institutions we think as important, like whatever government and military, it's already kind of there, and like finance, it's going to start coming up more and more. What is the actual outcome that is coming from it that is A, unpredictable, and B, somewhat catastrophic? And the best example there is some form of, like, it is a flash crash, effectively, right? Because a large number of algorithms working with each other, against each other, in tandem with each other as part of that ecosystem creates new sinks that are impossible to predict, and therefore not super easy for us to kind of guard against. And to me, the solution is like, it's the same one. The only way to guard against it is at the macro level. Like, you can't go solution by solution and say, unless we can perfectly predict the outcome of this particular system, we will let it go off and do what it wants to do. Because if you could perfectly predict the outcome of the system, we didn't really need the system in the first place. Like, it's kind of, arguing against the premise of the question in the first place. So the only way to do that is by having macro conditions which are non-negotiable, where we kind of create protections against. In the financial services world, this would be things like, a macro condition that says like, we don't like flash crashes, so we will prevent artificially the market from doing something crazy just because of the combination of a large number of algorithms kind of talking to each other. We will have to do something similar on the AI front as well, where if we don't want it to do certain outcomes in a particular system, we have to go from outcome first rather than sort of algo first. You're not going to prevent that by, I don't know, bounding the number of flops. Because even with a lower number of flops, we can find enough ways for it to kind of screw us up, assuming there's enough number of them that actually interact with each other. But the only way to stop that is step up a layer of aggregation, actually stop it from creating the chaos that we don't actually want it to do.
Yeah, and that kind of leads us into the various attempts to create legislation around AI. I was looking at the EU legislation, and I thought of the Beatles song "Mother Superior Jumped the Gun," because aren't we maybe overestimating current capabilities and underestimating complexity? Doesn't true AGI require multidisciplinary integration from a host of different disciplines? Maybe like if we're talking about AGI, because that's the other thing that I'm noticing. a lot of people, I think this is a classic case of people who have almost no understanding of what they're trying to regulate, thinking that they understand it completely, and then compounding the problem by, at least maybe it's just me, I'll get your opinion, but it seems to me like they have just already, let's assume AGI is already here, and let's regulate against that. And, then I just ask questions like, wouldn't we maybe need a workable theory of consciousness in humans and other animals or sentience? And do you guys even and gals even know what you are really doing? It seems to me, should we be inflicting human OS, which is great? I love it. We run it. And it unfortunately doesn't have a user's manual, but we're walking around with quantum computers up here in our noggins. And, it even makes me think kind of like Wittgenstein's "the limits of my language are the limits of my world." So what are your thoughts on that? I know in the book you also have a suggestion for the appropriate way at regulation. And I think you'd probably agree with me that at least specifically looking at the EU's version, that ain't it.
Yeah, I feel it's a bit like it's like a weird arms race where on the one hand people are saying that that is hugely important and hugely powerful and therefore it ought to be regulated, which is almost seen as a fait accompli, like it's like an assumed outcome. And then there's a bunch of other folks saying like, of course it has to be because the cost of inaction is so high that we have to kind of regulate it. Now, what's interesting here is that like the word regulation is used interchangeably in both of them. But as we both know, like regulations are not monolithic entities that kind of solve problems easily when they're created. Regulations are 10,000-page monstrosities that cause issues and create issues and solve issues all at the same time. And unless you know what you're regulating, I'm not entirely sure what you're creating all of this work, but why? I mean, what are you kind of solving for ultimately? So the EU regulation, I find, I mean, I'm in complete agreement with you, of course, because like if the point is that you do not want to encourage certain negative externalities, like you do not want people to have deep fakes, just to take one example, then you can do something targeted and specific against that, where you create high liabilities on against somebody who created it and like disseminated it. There's a different set of ways that you can go after it. The only way to kind of go directly after the creators of AI, as well as kind of regulating compute, is a fundamental misunderstanding of what you're actively regulating for in the first place. So to me, the question is a little bit like the people who are asking for regulation almost wanted to kind of roll back GPT-4. They did not want Llama 2 to be open sourced. And like we're here 8 months, a year afterwards. Like, can you admit you were wrong? Like, the world hasn't ended. Nobody has died. Like, more people are killed by vending machines than GPT-4. So at some point, like, we got to kind of admit that the core structure by which the argument is created is wrong. And there is one argument, which is the only argument whereby that particular form of regulation makes sense, which is the Yutkowskian argument that, like, if you don't stop it now, we are dead forever. If you believe that, but then you have to say you believe that, right? Then the regulators have to say, like, if you let the creation of GPT-5 come forth, or like Llama 3 come forth, all human life is dead. That's what we're scared about. Therefore, we should regulate. But nobody's saying that because that is absolutely crazy. So as a consequence, we're all kind of, tiptoeing around the actual giant issue that most people don't agree with, which is that you're not all going to die just because Llama 3 is created. It's just not going to happen. People will get positive impact and people will get negative impact, and there will be costs and there will be benefits. And as with all things technology, so far, the benefits seem to substantially outweigh the costs. And if you don't think that is going to be the case here, then please write a paper so that I can read it. Because that's all I'm saying. I'm saying like you need to demonstrate what the cost of this particular situation is. So most of these regulations are effectively trying to force a top-down view of what this ought to be like. And to me, it feels a little bit more like in the movies where the governments want to regulate a particular industry out. And in some sense, to me, it seems like EU, UK, in some sense, parts of the American legislature are all discussing it with their eyes firmly on like Mark Zuckerberg. Because like 6, 7 years ago, whatever, everyone is really angry that nobody regulated social media or regulated them enough. And now it's almost like we didn't regulate them enough, and apparently it caused all sorts of problems, and now we have to regulate this enough. And I feel like this transference of the argument is worse for both sides. Because even in social media, like you want to regulate them, but what do you want to do? Like, what would you like? You want Mark Zuckerberg to stop misinformation? It's like that is not a regulatory objective. Like, because you have to define misinformation. If you say you want Mark Zuckerberg to not let any, I don't know, Russian hackers on his platform, which has 3 billion people on it, by the way, then we can have a rational discussion about whether that's feasible and like, false positives and negatives, etc. But like stop misinformation is, I mean, you can say that for anything, right? Like, I mean, if you or I kind of went on and said the moon is blue, is that misinformation? I don't know. So there's a transference of guilt from the fact that nobody did anything about social media, and there's a huge amount of furor, combined with the fact that there's a huge fear mongering around the fact that these things can literally kill everybody. And as a result, we're getting ham-handed regulation coming top down about you need to license everything. License it with what? With respect to what? Are the regulators coming up with the evaluation methodologies, like I'm saying? Are they good enough at doing that? They want to test the frontier models. Great. Let them do it. We should also do it. Like, would you trust a government regulator to test software for bugs before you install it on your computer? Or would you rather do that yourself? Or do you want Norton antivirus? I mean, this is not we've had these discussions before with cyber and with the internet and with the mobile. So it's like, we're relitigating the same arguments in like a 10-year cycle, and it feels like we're stuck in Groundhog Day.
I love that answer for a variety of reasons. And one of the challenges that it just boggles my mind. I always think of Hitch's, that which can be asserted without evidence can be dismissed without evidence. And you do have this, what I would call lunatic wing, basically asserting, literally they're just screaming, bad, death is coming to it reminds me of the end is near with the guy with the placard on his. Yeah. And if you went up and talked to him and said, why is the end near? Because it is, because God told me, or whatever. And look, I am very much in favor of being realistic about the potential problems that will result from us developing this incredible technology. The challenge is we don't know what they are yet. We can speculate, we can hypothesize, we can do all of those things, but until we learn what they are, trying to make believe that we know right now what they're going to be just seems like a very foolish way to go about things, right? And it's like, yay, we invented fire. Oh, guess what? One of the greatest things in the world. It also is one of the most destructive things in the world. So did we say no more fire? No, we invented fire departments, fire alarms, fire extinguishers, fire regulations, fire doors. Right. And this iterative process as things move their way into society, that seems healthy to me, right? Because you don't know what the problem's going to be. There's another great quote, which is, no matter how smart somebody is, no matter how imaginative, no matter how clever, you cannot ask them to make a list of things that would never occur to them.
Of course.
And so I also this also is one of the underlying reasons why I'm such a big supporter of open source versus closed source. And, the author Robert Anton Wilson had a great piece that I'm just going to read it to you. He says, and I'm paraphrasing here, he says, a monopoly on the means of communication may define a ruling elite better than the Marxist means of production. Humans extend through their nervous systems all channels of communications like the written word, TV, radio, internet, search engines, and of course now AI. And then he says, whomever controls the media that allows access to that particular thing and downloads it into the human nervous system essentially controls the world. Remember the old one? He who controls the mediums controls the world.
Indeed.
And so my challenge with a closed source is, to me, that just evokes the images of a panopticon controlled by very few people. If Wilson's right, by extension, controlling what becomes part of every individual human's brain, right?
Right.
Wow, that's a lot of control. And
yes.
So, what do you think? Do you think that that's an overstatement of the power that this particular technology could have?
I don't believe so. I think that is broadly correct. There's this talking about regulation, there's this like Tacitus quote that something like the state is most corrupt when the laws are most multiplied, something like that.
Yeah. That's a great quote, by the way. Where the more corrupt the state, the greater the number of laws.
And in some sense, like I think about that particular quote in the way of like, there's a lot of things you can litigate in little bit by little bit, but overall, you have to have some level of faith that the people surrounding it want to use something for the best situation. I mean, that's one of the ways I think about it. Or like put it differently, I think about it as the difference between like a society led by virtue versus a society led by rules, for example. Like if you're led by virtue, you kind of know some of the right things to do and you might need a bit of guardrails. But for everything else, if you're continuously maximizing, you need more rules. And to me, like when you're thinking about the regulatory morass that kind of surrounds it, this is what reminds me of where you're trying to regulate it bit by bit, slice by slice, instead of kind of stepping back and asking the actual question of what do you want it to do in the first place? And I think like, if you think about it as a fuzzy processor, there's an enormous amount of benefit it can bring to all parties here. Because like I am a fairly sophisticated customer. Government regulations are confusing as hell to me. Tax is confusing, insurance is confusing. And like, if it's confusing to me, to the vast majority, it's effectively a worse black box than ChatGPT is. So do we want something that can relatively demystify it? I think that would be useful. But at the same time, if you create the technology that can do that, but put it entirely under leash, saying, there are certain types of, things that you're allowed to say or not allowed to say, then by definition, you're creating either a panopticon or like a misinformation fiat, right? So I'll tell you one of the funny things that I've been working on since I created a bit of an evaluation suite for a bunch of LLMs for various reasons, and I ran it against a bunch of the Chinese LLMs because I could. I mean, there's no reason to. So then the interesting things that come out from that is that they're really good. First of all, I should say that. However, like they're also clearly slanted in what they're actually allowed to say. Like if you ask it any questions about things around geopolitics, it's like hackles get raised a little bit and like it says specific things. If you ask it questions about economics, its hackles gets raised. If you ask about politics, of course, sometimes it just refuses to answer. Don't even mention Tiananmen Square. Like it is fascinating to see that like it has created an actually useful tool, which is like does coding really well. And like you ask it to create ASCII art of a dinosaur, it does pretty well. You ask it to name, planets in reverse order with different different languages for each. Like it does the things that you would want it to do, but it also means like you cannot put it into production anywhere you need any of that judgment. So like you cannot use it in a financial services institution. Because guess what? If you're making an investment decision, you cannot be influenced by, things that were hard coded into you. So similarly, like the only way you are going to be convinced about which ones you are most happy using are by ease of use and latency. Like it has to be easy to use in front of you, fast, etc., etc. But also like you can trust the advice coming from it. Like if I'm thinking about investing in something, I'm not going to call my friend up from Beijing to ask their opinion on a public line, right? Because like there's a set of information that comes back which is clearly biased. I would ask somebody that I trust. And that is the benefit here. So like to your point about the panopticon getting created, in a weird way, I think like we are heading towards a panopticon because if UK is surrounded by cameras, we have visual recognition that is beyond the bazoo. You can go into countries now with just your face as your ID, especially in the Middle East. It started. So that's here in some sense, whether we want to or not. Now the question is, do we just bow down and say like, hey, you guys take care of the models, do that, and like we'll just continue living our lives? Or do you want some semblance of the benefits of that in with you? I mean, I grew up in India, right? Like, so I had an Indian passport for a very long time, which means traveling anywhere is an enormous pain in the ass. And like, you have to get all sorts of visas and stamps. And I wished for a big brother to exist who just knew everything about me so that I didn't have to do it. Like, I'm like, just take everything. What do you want? Bank account, address, take all the information. Just stop me from filling out forms. We have the second part. We do not have the first part. We have something that knows everything about me. I still got to fill out forms. So I'm like, maybe we should even the playing field a little bit.
Yeah, and I think that the thing that scares me is that that your last bit there. I too, when watching one of the Matt Damon movies where he plays the superhero, and I'm just thinking, God, it would be really great if we actually had those guys.
Yeah.
The Born
Right?
Identity.
Yeah.
Right. And then we don't. So we have this kind of idealized version, like, yeah, of course, we can just send some of our super troopers over there and they'll take care of everything. Yeah,
Yeah.
but we don't have those guys.
Exactly.
It's like Big Brother is actually little brother who's not so terribly bright, even
Yeah.
though he's got access to so much vast information. You also posit in the book that AI will be very helpful in reducing said bureaucracy that we're discussing
Yes.
and lamenting right now. And one of the thoughts that I had as I was reading it, and would love you to elaborate on your view, is how do you think in that specific domain use case, how do you think it'll be able to navigate the principal agent problem without introducing new dimensions of complexity or ethical dilemmas, et cetera? And if it does that, how do we solve them?
So I think in some sense it will do some part of that. But think about the current status quo where we already have a principal agent problem, or rather a principal agent problem, where I'm the principal who wants something done. I am also the principal who is trying to do something. Then there is the agent who is actually going off and kind of whatever the bureaucracy, the interface issue in the middle. The one part where I think it'll be super useful is purely the unstructured to structured and structured to unstructured part of it. Where if you imagine a large amount of your bureaucratic face-offs against the system, it's because the system has a monolithic view, or at least like a box checking view of a large number of pieces of information that are relevant to you, Jimosh, honestly, me, Rohit Krishnan, and try to get those pieces of information. If it matches it, it's like does a checksum and you're happy days, right? I mean, some form of that. The pain for us is like, A, we don't fully understand what question is being asked, and B, like once you understand it, the amount of effort to go to kind of get those pieces of information and actually do it in the right order and fill it and like file it is enormous. I mean, I don't know how large the tax filing industry is in the United States, but it is way bigger than it ought to be, right? Like it's a these are examples of creeping complexity that hurts everybody on an ongoing basis. Not to mention things like a health insurance or any kind of insurance for that matter, not to like purchasing anything, stock purchases, houses. Like there's an enormous level of complexity where you do not have a solid interface. So given predictability in terms of being able to convert your unstructured pieces of information and needs and wants and hopes into some form of a structure that can interface with the bureaucracy. Same on the bureaucratic side, for them to read this incoming information and actually clean the useful bits rather than filing it away and hoping that something beneficial will come out of it. On both sides, I think it can dramatically reduce bureaucracy. The ethical questions come about later. Once they come about in the form of like, number one, what happens if a mistake is made? And to me, it's like, this is an empirical question. It's a little bit like, are the mistakes made going to be more or less than it is made today? And if it is like less, we're fine. Like you just have to, if I file something and it's wrong, you refile it because that's what happens today, right? That's the normal thing to do. And if the answer is like, yes, you have to refile it occasionally when things go wrong. However, it is okay, even if you have to refile it, because like your AI got it wrong is an okay excuse. And it's in fact a way better excuse than my CPA got it wrong, which happens way more often like than it has any right to, or my doctor got it wrong. Happens way more often than it has any right to. The second part of it is like, how do you trust the AI to be able to do that on your behalf? And that is one where like the only way you will trust it is if you actually see it used enough times that you can trust it in some sense. If it does fine on several times, then you will like, it kind of knows what it's doing in this sense, and you kind of need to do a overall sense check perhaps. Or you might just use it as I use it regularly on anything regulatory or legal that like, or even medical. I sense check, right? Because AI is tireless and I can give it hundreds of different scenarios and ask it the same question in different ways. It gives me a comprehensive list of questions. Like I did it recently for sort of a family member had a health issue. And I was like, one way that I would check it is I want to get the holistic sense of information. Because when I talk to the doctor, I get few minutes, whatever, right? I mean, you get one view. However, once I get the entirety of the medical file, I can actually slice it in like 100 different ways and collect my thoughts and give a sense of these are all of the possibilities and hypotheses and use that to have an informed conversation with the doctor. So then his 10 minutes is used much better by me and him because he's not giving me information. I already have all the information. Now we're just actually talking about questions and answers, which is a much better way of interacting with it. So to me, like this is the way that it reduces, you can see that it reduces complexity in the interactions that we already do with a large number of these impersonal institutions. It can dramatically increase the number of ways in which we become far better agents of ourselves. Like if I have I don't know, tax filing issue, I don't even know where to start in terms of defining the question to ask it. However, if we can actually get better at that, that is better for me, better for the tax agent, better for the IRS. Like everyone, this is one of those few situations where everyone's a winner, perhaps except the CPA that I used to pay a huge amount of cash to. So like there's a set of different ways that you can think about where given you have to evaluate it, you have to understand whether the answers that are coming out are sensible and straightforward. That is on you. We'll have public ways of doing it. We already kind of are starting, but we need far better evaluation metrics in my opinion. And then having done that, you can graduate the usage of those in real life situations with a little bit of the current example, which is there's caveat emptor, and maybe worst case, you will have to create a legal shield around it where you can purchase insurance against it. So we can get there even with the current AI, which surprised me, honestly, because I wasn't sure that that was the conclusion I was shooting for. It'll keep getting better, but there's a number of ways in which we can finally, for the first time, at least in my lifetime, cut the red tape involved in actually interfacing with impersonal institutions.
Yeah, and you made a point there that I would love to extend a little, and that is the compared to what. It's often the case that as you point out, well, it got it wrong, so therefore we will never use this particular technology, much like they do with driverless cars, right?
Exactly.
A driverless car crashed and killed somebody. Take them all off the roads. They are absolutely not to be allowed. Well, wait a minute. Compared to what? Do you know how many crashes killed people with a human behind the wheel? A hell of a lot more than with the driverless car. So it seems to me that we have these planted axioms in the argument, which sometimes make me wonder whether the other side is arguing in good faith. Because, like, compared to what's actually happening right now when people are filling out their taxes or getting their medical information or getting their insurance, or compared to some state of perfection that will never be reached by anything, never has been reached by anything ever in the past. And sometimes it just drives me mad when I see these comparisons. Like, compared to perfection, well, yeah, then let's just not do anything. Let's all sit in caves and just, be nothing.
I mean, precisely, right? I think to me that, it exemplifies the I mean, people are always worried about what things can go wrong because it is much easier to see than like how things can go right. Because especially because if you already knew all of the ways in which things could go right, then we would be living in a very like weird world because you can't predict the future. I like when it's like when the first iPhone came out, like everyone was predicting all the ways in which it was wrong. Right? Like it only had 2G, it didn't have 3G, couldn't do copy paste, was heavy, like glass would break if it fell. And guess what? All of those things were correct. Because none of it mattered. Because we moved past it by teaching us and teaching them how to actually use this new thing in the first place. The same way when computers first started getting introduced into workplaces, tons of complaint, it'll get things wrong and people whatever. All of the complaints were correct. However, we changed around it, which is how we do things better. We do things like far more efficiently, which is the kind of metric that we should judge these things by. So I feel like a lot of the times when you argue against some sorts of progress, it is much easier to hold on to oh yeah, but see, it got it wrong here. Which is, the thing is the question to ask is, can we fix it? And also is that error okay to have? Now, there are some errors that are not okay to have. You don't want to have an accidental nuclear explosion, right? Fine. So there are certain systems where you do need high levels of determinacy and incredible numbers of redundant layers so that some accidents are just too bad and we do not want it to happen. But that's not what we're talking about. We're talking about helping people's lives as it exists today with enormous degrees of error. I mean, the number of people that I have spoken to who have had medical misdiagnoses, legal bill issues because they were advised wrongly, tax issues, it's staggering. I mean, you ask 3 experts, you get 3 different opinions. And if that's the situation as it exists today, then let's make it efficient and actually cut it out. And then we can come back and fix stuff later. But this is a waste otherwise.
Yeah. Again, amen to that. But also, as I was listening to you describe your family member's medical issue, I hope that it was resolved.
It was okay.
It did make me something I've been giving a lot of thought to and concerns me a bit is that have we come up with a technology that is, I don't know, people who are very clever or very smart are already, at least among my group, are already using multimodal AI for a variety of things. Do you think that? And it also guides my idea, AI everywhere. When AI becomes as invisible as electricity, then maybe this worry about the super smart people over here using it to its maximum effectiveness are just going to bury, the people who aren't using it. It's like Ahmad Musteek, who is the founder of Stability AI, which I'm an investor in. He says AI is not going to destroy humanity or human jobs. Humans using AI will destroy humans who refuse to use it. What do you think?
I mean, I think that's the positive view of the world, right? Like humans using better technology enable things to get done much better, enabling all of us to have far better standards of living as time goes on. That's the dream. I mean, there's a reason we only employ a minuscule fraction of the people who used to work in the agriculture sector compared to like, the vast majority a century ago. Like that is progress. So the question now is twofold, right? I think, there are two problem areas. Problem number one is like, to our earlier conversation, what happens if the mistakes that are being made are different mistakes to what the people are making, which will happen. But like that's what people are scared of. Not that like it'll make mistakes, but it makes different mistakes. And we're used to these mistakes. But like, and some of that I think is cultural because it's like, get used to new mistakes. That is the job of growing up, right? In some sense. So that's fine. The second bit is like, what happens if this happens really fast? Which is a worry and a bigger concern and potential social issue. Potential, I say. And in the even if we posit that is likely to happen, even then, like stopping it from happening by fiat is not going to work. So to me, like the question then becomes, we should perhaps much push the question of how much better, how much more you need to experiment and innovate in your daily work so that you can actually do more things, far more, rather than saying like, let's go the Luddite way a little bit and kind of stem back the speed with which the machines are actually coming in to kind of take our jobs. The good news here is that the amount of effort it takes for getting an AI to take your job today is remarkably high. It's not small, except for, like I said, sort of small bits and pieces where you can actually highly and tightly define the job scope and therefore make it amenable to automation or creation in some sense. But that was kind of always the case, right? And I feel really, really bad for people whose livelihoods are being impacted by doing this. And we need to do everything in our power to help them socially as well as educationally in order to kind of do better. But stopping it is not the right method to do that. Like, it's like, it reminds me a little bit like the closest analogy, and I was thinking about this. The closest analogy was uh, like stocks used to be traded by hand, right? Open outcry. It's not anymore. And this didn't happen over generations. It happened pretty fast. Like like electronic trading came in and it kind of moved things out. And like, guess what? People found new instruments, people found new ways to trade, and like a whole series of people needed to find new ways to actually deal with the reality, and which was much better and far more efficient for everybody concerned. And like the fear of potential displacement or like the slight level of complexity and chaos should not stop us from saying like, let's not bring in the benefits, which are, 100x, 1000x what the costs are, because we can see the costs. Like we can actually see it. And I mean, this is an election year. Every year here, at least in the United States, you talk about this, like whatever, coal belt and so on, about, bemoaning the loss of certain types of jobs. And I think part of the reason that exists is because like, you need to have the conversation that like there are certain jobs that once gone don't come back for good reason because they're not as valuable anymore. So we need to get better jobs, which is the right way to kind of go about it. Now, like there's the adjustment period, like you need better, social safety nets and a set of ways in which you can help the people who have lost their jobs. But there is no way to kind of stem that tide. And I don't think we should try to, because I feel that would be doing a disservice to humanity.
Can not agree more with you on that. It's like I was chatting with a team member yesterday and talking about the ice harvesting industry in New England.
Yes.
Right? So thousands of men lost their jobs when we electrified kitchens. They used to literally saw the ice from the frozen river, transport it to the processing facility where they would cut it into chunks, put sawdust on it. And then the iceman would take his truck around delivering ice for your ice box, which some people still call refrigerators, right? But there is cultural continuity there. But those were bad, hard jobs.
Yes. I mean, that's the
And
thing. The same thing exists in logging, right? I mean, like there are the history of our, I don't know, species. Like I had this deep dive into progress at some point, and one of the cool things is like the number of ways in which we have bettered ourselves by leapfrogging is phenomenal, which is the most beautiful part of it. Like, name anything, whaling, another, not to mention exceptionally hard and dangerous job that nobody actually needs to do anymore. But I think the speed of adjustment here is one cause that often people kind of talk about. But the solution to the speed of adjustment is adjustment on the other side, rather than, uh, naively stopping everything on the first place. Because even if all of AI progress today just stops, like nobody does any research anymore, the progress, the speed with which it will actually implement the real world is not going to change all that much. Because it's just there's way too much benefit in these technologies to not be able to use them in the first place. So it behooves us to know how to use it.
completely agree. And you brought up creativity, which is another thing you cover in your book. And one of the questions that I had, because I share your view, I share the view that this is going to be almost like godlike powers for humans and leverage for their creativity. But one of the things that I've thought about a lot is essentially, I guess we could borrow a title and call it a critique of pure reason. A lot of Peter Watts says we're not thinking machines, we're feeling machines who happen to think. And a lot of creativity comes from these leaps of imagination. Where, I mean, I think of Einstein, I think of Tesla, I think of, a variety of people. When you look into when they were talking about how they came up with ideas, it was not in a rational or any way ordered way. It was literally a leap up the chain, so to speak. And many would say that was an intuitive leap up, which leads me to say that I think that much of the use cases around creativity are going to almost require a Centaur model, i.e., man plus machine. Show me where I'm wrong. Help me out where that's an incorrect view.
I don't think you are wrong. I think the only caveat or perhaps addition that I would make is like Centaur models work best in areas which are not directly entirely competitive with the same things that the AIs do, unless you find joy in doing it, because then it's a self-fulfilling kind of prophecy. So to me, like currently, and at least for the immediate future, AI is best used in areas where you can either automate part of your own job and yourself, and also use it together with you in order to make your ultimate goal better. It's just like any tech. We are all centaurs already, right? Like we live most of our lives on digital technology connected with other human beings. We are part of some weird form of a hive mind, and we are all kind of cyborgs. This is a fact. So then the question is, how much more integration would you like in different facets so that you can actually perform some of these things better? And the answer is all of them. Now, there might be some things where, guess what? Like if you like drawing for fun, you're probably still going to like drawing for fun, despite the fact that if you do want to kind of make a profession out of it, there are some things that the AI will be able to do much better. And you, as somebody who actually understands it and can use it better and knows the intricacies of drawing, will be able to direct it and make use of it in ways that, like, me as somebody who doesn't, can't. Like, your knowledge and education in doing that particular thing translates to how much better you can actually do something. It's like giving yourself a boost, right? Everyone gets a boost kind of question. That's kind of not going anywhere. So I feel to me, the education part is super interesting and important, because ultimately the only way we are going to be able to make our peace with it is probably the wrong way to kind of put it. But at least like the only way we are going to be able to kind of utilize it to the largest extent is if we get much more comfortable using it on a regular basis. And occasionally I've had discussions with like artists and people who kind of feel very strongly against AI. And I respect some of their opinions, not all of them at all, but like around the fact it does not have a soul, or, those kinds of opinions. And I'm like, leaving aside all of the metaphysical stuff, I get what you're saying, but also that's your job, right? Like that's, you know what I mean? Like, why would you expect it to have a soul? Like your work with it is what will imbue it with sort of the creative characteristics that makes it better. Like that is the entire purpose. So which comes back to your Centaur model. But what that means is like, I don't know, you just want a silly illustration to do something for your blog or like, your little product launch. You don't care. Like you don't need it. However, if you want to do anything genuinely creative and artistic, you need it because that's the only way that you're going to be able to create something that is state of the art. Because we're all raising the waterline, right? Like I mean, it's a continuous pushing up of what is the best that something can be. Doesn't mean that you always need to beat it, but at the very least, it means that your aspirations are much higher than where they used to be before, and you do kind of need to like fight for that. I think it's the Heinlein quote, like man is not a rational animal, he's a rationalization animal. Like it exists for a large number of these decisions. We are not thinking about it rationally. We are rationalizing by saying, I hate the fact that a machine did it, therefore I think it is bad, as opposed to going at it the other way around and solving for the problem that you want, which is I want to create something, a novel, a movie, an image, anything. And I want to use whatever tools I have at my disposal to make my vision come to fruition, as opposed to sort of flipping around and saying, oh no, none of my visions have anywhere to go anymore. Like we are all going to be stuck here forever, which is a defeatist attitude. I don't think it's helpful.
Yeah, and that's part of human OS. I mean, there's it's probably an apocryphal story, but the first Sumerian cuneiform found was a lament that all the good poems had already been written.
Yes,
but
turns out not true.
Turns out that was incorrect. But as far as the artists, as we were chatting before we started to record, I've been collecting contemporary art for a long time. Yep. I have a lot of friends who are artists. Many of them have come to me, and since we're friends, they're like, "Hey, I'm feeling like really exposed here." Yeah. And I give similar advice to what you just gave. We actually invested in a seed stage company called Juan, and what it does is it's actually a device with which you can draw, but it's AI enabled. And what it allows you to do is iterate against your own work. And we have been having once it gets in the hands of sometimes even formerly hostile artists.
Yes.
It's like night and day. They use it for a day and they're like, oh, this is the coolest thing in the world. Because essentially they're understanding, the way I look at it is they're not thinking about it in terms of AI. They're thinking about it in terms of, oh, just another tool. And oh my God, look at what this tool can do. It can iterate.
Precisely.
They do the sketch, especially with graphic artists, love it. They do the sketch and then they say to the AI, do 10 variations on this. And the AI does, and they're iterating on their own work. But it's like having like the best sparring partner in the world yourself.
You know what the cool thing about that is? There is an implicit change there where before you start using it, you kind of confuse in your mind a bunch of notions about like sentience and consciousness and an alien being and all of these kinds of things associated with something that produces subpar work, better work, whatever. But once you start using it, none of that matters. It's a tool. Like exactly. You suddenly, the boundaries become slightly less fuzzy. You realize that it doesn't have wants and needs and whatever, but you can use it to create what you want, as opposed to like it existing as an independent entity with, whatever alien sentience that it has on its own. So the funniest thing about the funniest thing to me in this entire process has been like, you see that there's been an enormous number of questions and decisions that have existed in neuroscience and consciousness research with, depending on who you ask, minimal progress. And in many ways, we now have something that we can actually poke at the neurons, right? Like the highest resolution image of the human brain pales in comparison with you being able to poke at the gradient of like a, you know, attention-based transformer model. Because it's just now you can actually test some of these things and actually have early stage, very minimal, empirical, some understanding of what might be going on in our heads. It doesn't translate one to one. We are not transformer models internally, not even the individual cortical columns, I suspect. However, that is, we finally can do empirical research on some of these problems, which we've all put in it's like God or, infinite. You put a placeholder around it. There's a bunch of feelings associated with that word. And anytime that word gets triggered, all of those feelings kind of pop up, as opposed to them being actively, you know, like a C++ pointer kind of pointing to something genuine. This just ends up being like this amorphous blob that you use only when you want to get angry at an argument.
Right. But, on that point, like if you consider integrated information theory, for example, which says that consciousness develops from the integration of information in complex systems through a variety of that happening. You also make the argument in your book that AGI doesn't need to be conscious. What about it if we look at it through the lens of integrated information theory, and consciousness spontaneously emerges? Do you have a plan for that?
I don't have a plan for that. I hope for that, but I don't have a plan for that. I think
I have a friend who's a wag, and he said, "Just pull out the plug."
I mean, honestly, yeah. But like, let me put it this way, right? So the one of the clear thoughts in my mind when I was writing the book was that I wanted to be able to explicitly explain where we were without needing to posit huge new future developments that might come. So,
which I really appreciated about the book, by the way.
Yeah, because like I feel like once you expect a future development to do X, then you can kind of justify anything you want, right? It's a little bit like whatever James Cameron making his Avatar movies. Every like he just kind of expects something crazy to come about, and then like waits 10 years and something completely different pops out. But like, so with respect to IIT, I'm not an expert, although like I read a little bit about it. I think the core conceit, as I understand it, or at least one part of the core conceit, is that it veers fairly close to like a panpsychism argument, where there is sufficient levels of information that is integrated is what kind of pops out a form of sentience or consciousness. The problem to me is that I don't see how that's falsifiable in any meaningful sense. And as a consequence, I am perfectly happy believing it in the abstract. However, I don't fully understand how to think about it in a real world scenario. That said, let me kind of place it in context. We are mostly talking today about like, large language models to a large extent. I mean, we briefly talked about stability and like their diffusion models and stuff like that. All of these are, even though they're powerful, highly blunt instruments, right? Like, I mean, you have to throw in terabytes of text in order to make it create some interesting semblance. Like, I mean, I did this weird calculation at some point, and I think it's like, whatever, maybe 10 to 50x as good as the current zip or whatever other compression algorithm. So they are much better at retaining information and doing cross connections between itself. Now, there was this Jan LeCun's like recent video somewhere where he talks about the difference between, one of these models and like what a 4-year-old child sees, like the amount of information that he or she sees by the time she's 4. And it's like a huge amount of information that they kind of taken in video. But the thing is, like, for us as humans or any sentient animal that we know of, they have a pre-made template, helpfully guided by evolution inside our heads that enables the processing of the information in the right format. But they also have an enormous multimodal set of receptacles that can take in information and actually integrate it in our mind. They might not be all transformers or all diffusion or some new architecture thereof. It's some way of making sense of the fact that, like, a 2-year-old walking around sees something, says something, hears something, and is able to integrate all of that together and then be able to come up with some sort of a world model that he or she accurately perceives, right? there is a chair there is not a theoretical sentiment or a hallucination, but it is something that they can accurately perceive. And that level of groundedness is something that no AI today comes even close to actually having, which is interesting because what that tells us is like there is a large number of leaps that we might need to make in order to create something like that. So to me, the question is, I define it in the book as something like, you know, if you want to do a scientific experiment, which involves some level of supposition and some levels of like induction, how could you think about creating an AI that is able to do something equivalent? And the answer, in some sense, is like we probably don't need to think about it in terms of completely new architecture, but can we try to get there through a fair bit of hard work from what we have today by actually connecting them together, creating an infrastructure around them, having the right kind of redundancy, having the right kind of memory, et cetera, et cetera, et cetera. That is the kind of crux of the question. Because when we kind of posit it closer towards what we are, which are much more complex beings that run on whatever 20 watts of power, that is a order of magnitude different. And at least my hypothesis is that we're not going to stumble upon consciousness by mistake. I don't think there is a large enough corpus where automatically it just starts up. Because autoregressive models don't work like that. I don't think that's how consciousness emerges. In order for that to happen, we would probably require a transformer equivalent LLM for each cortical column that is actually interconnected and trained together with multimodal information that is coming across sort of, I don't know, call it years, but for them in like, subjective time, maybe not years, including things like proprioception, walking around, like there's a set of modalities that are required for that innate sense of the physical world to be embedded so that on top of it, you can actually learn different things. And maybe at that point, would there be sentience that emerges or consciousness? I have no idea. I mean, I hope so, because I'd love to meet a alien life form in my lifetime. I'm not nearly as scared of that, but I'm not entirely sure that that is, I don't think we should make decisions on the basis of that because nobody knows at this point.
Right. I agree. Let's shift gears a bit because you spent a lot of time as a venture capitalist,
I did.
and still are doing that. And I'm curious about your view on what's going on with the tech giants. We all know who they are: Microsoft, Google, Amazon, Nvidia, et al. Do you think that they're creating a potentially hostile environment by doing a little bit of a shell game and saying that, we're investing 10 billion and then you investigate fine print and 9 billion of it is credits that are going to go right back to their cloud computing. And then they're doing it at these sky high valuations that seems to me to put the, good old invented in the garage startup in almost an impossible place. What are your thoughts on that disconnect between that sort of funding, which is going to very specific players like OpenAI, Anthropic, et cetera, and creating this hurdle rate? I can't remember, what is OpenAI's last valuation, like
89,
90,
I think, or
$90 billion.
You're right.
And especially when you have the sleight of hand with most of that being credits that go right back to Microsoft.
Yeah.
And then you've got to create enough liquidity in a secondary market for all those OpenAI option holders who are like, ooh, I love $90 billion valuations. It just seems to me that it's not an outright flat market failure, but it does seem to be tilting the playing field quite a bit to me. What do you think about that?
So, as someone who has a bit of my retirement savings invested in the big tech, I would say thank you, Satya. He's done well. Historically, like if you think about, let's take a couple of examples in tech, right? IBM used to do this thing somewhere in the mid 20th century, later half of the 20th century, where computers used to be incredibly expensive in the mainframe era, and they used to help companies finance the purchase of the companies. purchase mainframes. To me, it reminds me a little bit of that because IBM had so much money, they could fund their customers to become their customers and get like a little bit on top, effectively. And it reminds me a little bit of that, right? I think, did Rolls-Royce do something similar? I have this vague memory that Rolls-Royce did something similar as well, where they're like,
that one I
they
don't
did
know.
something with the
The
airlines.
IBM story is well known, but I don't know the
Yeah,
Rolls Royce.
I think they did something similar with airlines, where because like they want to do pay per use or pay per hour or something like that instead of actually paying it upfront because the airlines couldn't do it and therefore they got a little bit of bump, etc. But anyway, historical asides aside, I think the interesting thing here is that um, the big tech dominance in tech is clear. And it's clear in sort of a couple of different ways. If you think about the largest tech companies today, most of them are the largest tech companies 10 years ago. Like if you think about the largest venture-backed tech company since, I don't know, that IPO'd since 2012 or something, it's probably like since Facebook, effectively. There's not been one that has crossed 100 billion. I think like ServiceNow is probably the closest that has come to it. So in some sense, um, the only arguments of companies which are not against that in the private market is Stripe, which hit close to 100, then came back down. SpaceX, which is Elon magic. So every number is imaginary over there. And I don't really know what the right valuation is likely to be. But there is a dearth of enormously large companies that actually exist in the venture-backed market, which used to exist in the prior market. So in a weird way, the way the VCs actually made money is not just by kind of making sure that the companies become as big as Google, but actually acting as late stage financiers so that the public market effectively got privatized. So like you would have been able to purchase some of these public companies at like 3, 4, 5, 10 billion valuations, worst case scenario. I don't know what Facebook went public at, but it wasn't anything crazy compared to, it was crazy then, not compared to today. But instead, you would hold on till it's like 100 billion and it goes public and it kind of treads water or like goes up a little bit, comes down a little bit, right? Like Snowflake is a good example. What this basically means is that for today's AI companies is kind of caught in a bit of a bind because on the one hand, they have enormous capex requirements if you're building foundational models or GPUs, etc. The hyperscalers have more money than God, and they can kind of they can actually pay them to use their credits, which means the money that they're giving out mostly is coming back in as revenue. If it comes back in as revenue to Microsoft and Azure, that gives them like a 5-10x boost instantly, which in their market cap. So they're like, this is a perfect trade for them on top of the equity and the benefits that they're actually getting. What this tells me is like that game is kind of shut for startups to play in. If your game is, I am also going to get some GPUs and I'm also going to play in the hyperscaler game and I'm going to provide access to, I don't know, fine tuning models, whatever it might be, I don't see a pathway to creating a large company basically by doing that. I genuinely, it reminds me a little bit about Elasticsearch fight with AWS and because it was open source, AWS rolled their own and they're kind of like, it's history at this point, right? Or many of the database fights at this point. So if you're a early stage like startup, to me, there are two paths which are kind of not trodden upon by any of these large companies, which is number one, go vertical, because like, no matter what you think about how smart these models are, how smart they'll get in the next year or the year after that, the world, as I have seen, is infinitely complex. It's fractally complex is a better word, which means like if you wanted to do a job in a particular domain, the only way for you to do it is to explain that domain to the model and help understand what it can actually do and not do. This is not trivial. This is in every domain is complicated. I was talking to sort of some advanced manufacturing folks recently. Like if you think about 3D printing, it's heavily complicated. 3D printing metals is complicated at a molecular level because you can't predict exactly how the molecules react at any point. The powder has to be in the perfect format. This is not something an AI can just like figure out just because it's infinitely smart. So as a consequence, the deeper you go, the more narrower you go, the better chance you have at creating an actual company that builds interesting and useful things. Number two is that you can try to shoot for genuine algorithmic, I don't know, step changes, if you will. Transformers came out from a bunch of researchers in Google in 2017. Could you recreate something like that? Quite possibly. I know folks like Sakana are trying to do that in Japan, So there is a possibility for some new revolutions there. It's not really venture capital, or maybe it is venture capital as it was practiced in the 80s, because effectively you're funding a research lab and hoping that research comes out. So it's closer to like a privatized Bell Labs that you're funding. And maybe it works and maybe it doesn't, but it's a weird new form of funding dynamic that nobody's kind of caught on to. So put those two things together. What do I see? Like, number one, I mean, IBM used to do this. They had the heavy monopoly, and the only reason they got sort of kicked to the curb a little bit was A, antitrust made them incredibly paranoid about doing anything. Lawyers basically ran the company for 10 years. And B, like, there were genuine new innovations that two people in a garage actually could do, which was kind of a algorithmic step up to create some kind of software that could actually make an inroad into this particular domain. So I think it is something similar. I do think that if you think about the best startups to come out of this era, the chances are, I don't know whether the chances are that all of them will require $10 billion of GPU to be successful, because I think that's not likely to happen. Because if it required CapEx investment, then there are already enough people who can deploy CapEx, right? Even if it needed a billion in CapEx investment, the number of companies and organizations and institutions and individuals in the world who could deploy a billion into one of these companies is staggeringly large. So it cannot be CapEx. It has to be some combination of unique insight and knowledge and know-how that needs to happen for you to be able to create something that is meaningful to a particular section. So that is very much where my kind of lens is with respect to the market, that you have to solve, like, the big companies have built the base very nicely, and the base keeps going up, which is wonderful. But if you want to create something, you have to solve someone's real problem on the ground. And all of the things that we've been talking about during the conversation today, whether it's on getting better evaluations, understanding the process better, if you're going to be you need to be embedded in those individual domains for you to be able to do it. So I don't know what another analogy is, like cloud. When it came up, there were a bunch of other cloud companies that tried to start and compete with, AWS and Microsoft and Google. None of them really succeeded, right? Like even the big tech companies didn't really succeed. Like Oracle has its own cloud, but it's not like super successful. The only ones that did succeed was saying like, oh, you're providing the base. We will actually go ahead and make that useful and make use of that to build something genuinely meaningful on top of it. By providing something that you couldn't get from the regular cloud companies, whether that is, folks like Snowflake or whatever, Databricks, name any company that has kind of come out of that era, you have to provide a service that is Delta on top, which two people in a garage can genuinely do, because it is something overlooked incorrectly by the large companies in a particular niche where they genuinely just don't see a huge amount of value.
Yeah. I could talk to you all day. I'm getting the hook from my producer here. I always babble on, as he says. But I got to ask one final question, and then we're going to get to making you the emperor of the world again.
Ooh, okay.
So the question revolves around something that I've been hearing more and more about, and from really, really smart people, way smarter than me. And it's the idea that, are we running out of useful data to train these models on? I have an opinion about this, but I want to hear your opinion. And then wrapped in that, a question: do you think like some of the largest purely data driven companies, wouldn't it maybe be smart for them to acquire a fully integrated AI outfit, because that data is behind their firewalls, and it isn't on the pile, so to speak,
Right.
which is what all of these other ones were based on. So two-part question: are we running out of data? And I'd also like your view on synthetic data. I also have a view on that, but I want to hear yours. And then, do you think that might be clever for some of the bigger data companies to just go acquire a full stack AI company, marry their behind the firewall data, and God knows what happens?
I'll do the second one first. The answer to the second one is yes, if they can afford it. I don't know whether they can, honestly, but But yes, now comes the caveat, which is actually the first question. So there was this big, especially over the last decade, everyone started talking about data as the new oil, and we finally found a place where data is the new oil. But there is a problem here, which is that while we need large quantities, high heterogeneity, and high quality of the data that is coming in, a priori, it is very difficult to use that data to help easily extrapolate in some sense to what the benefits of using that data is likely to be. So in some sense, you know, the perfect example is maybe something like Bloomberg GPT, which trained on proprietary data that is very hard to get for very large sort of, many people. Turns out like they didn't get a huge boost by just using their data because which is one case in point, and there are others of how it is insufficient for you to have data that nobody else has for you to be able to make use of it and create your own model. Instead, what you need is data that nobody else can have or extrapolate towards, which is a much higher bar, right? Because the LLMs are, in some sense, extrapolation engines. It finds implicit associations within all sorts of information that is fed into it. So implicit in that is the assumption that if the data that you have could have been extrapolated from existing data in some sense, which a lot of the data behind firewalls are, then effectively by itself, that is insufficient. That said, I do not believe that we are anywhere close to sort of the end of data in some sense, because there exists an enormous number of new modalities and capture mechanisms to get data that we don't have. I mean, we're kind of today at like the pi plus plus era, where we're talking about internet corpus or taking some non-internet corpus and making it internet corpus. But if you think about the vast majority of data that exists around us, it's not just the data that exists on the internet, right? It's multimodal information that comes from everywhere. Like it is the like proprioception models. It's there is a set of different types of data that you cannot easily extrapolate from existing data sets, which is kind of where the value is. So that is my broad assumption. What does that mean practically? Sets of data that I'm super interested in. Interesting visual data, I think, is vastly underrated. Audio, vastly underrated. Name your modality. Smell, I don't know. Vastly underrated. Things like there was the Berkeley researchers who helped the robot walk around in order to capture data. The data about how it walks and how it learns in itself is actually vastly underrated. And lastly, specifically in terms of companies and organizations, process data, vastly underrated. And illegible. Mostly it's not captured, but that's where all of the value is, right? If you think about it. If you think about how do you make decision inside a large corporation or a company, yeah, you have some written documentation, but that's not what matters, I talk to them, they talk to them, we do a meeting together, we capture a bunch of information, we write it down, we iterate on it, then we talk to 3 other people, do some it is these 200 different things that interact with each other that actually creates the final output, and that process has almost all of the magic instead of the endpoint. So I think there is an enormous amount of data that we're not capturing. Synthetic data is an interesting one. I am relatively positive on it as I built this small thing to test like a hypothesis that could you tune a GPT on its own output like a long time ago. And it was cute and it was cool and it worked. And I was like curiosity satisfied. But recently there was a new paper out where people actually took a new method of training DPO and applied it to the outputs and used the same LLM as a judge. And suddenly it started performing much better. Now, the caveat here is that I do think that this will work much better in terms of training the AIs to do certain things much faster. Or it's like the Kuhnian paradigm shift versus in paradigm progress. I think synthetic data will help dramatically in paradigm progress. I don't see how it can help it shift in any meaningful paradigm shift, because it has no way to extrapolate the information that it doesn't have. But within the information that it has, it can create much better data and be able to jump up. So it can go from, I don't know, Llama 2 to Llama 3 performance by using synthetic data and all sorts of clever tricks, perhaps. But it's not going to be able to go from GPT-2 to GPT-4 type kind of leaps, if that makes sense.
It does. Well, as I said, I always have a wonderful time talking to you, Rohit. Now we're going to make you emperor of the world, and you
Cool.
played this game with us in the past.
I
You
have.
can't you can't kill anyone, and you can't put anyone in a re-education camp, and you can't stick anyone in a strange loop that is just
No exit.
endlessly has no exit. But you can incept the entire population of the world. We're going to hand you a magical microphone, and you can speak two things into it, and all 8 billion plus or minus 100 million people on the planet will wake up whenever their tomorrow is, and they're going to think, I just had two of the most wonderful thoughts, and here's the key, and I'm going to begin acting on them immediately. What two things are you going to incept?
Oh gosh, I'm really hopeful I'm not going to repeat my old ones, but it's compounded by the problem that I don't remember what I said before exactly. But I'll tell you what's on my mind right now, which is the right way to do this. Number one, I think I would tell more people to read more fiction. Um, it's compounded by like I've been having over the last year, I think one of the things that I noticed while I'm writing as well as talking to a large number of people is that there is an enormous number of folks who are super excited about reading nonfiction, and there's a lot of good books that are coming out, and it is wonderful in sort of all sorts of ways. I don't need to tell you that. However, I feel like the role of imagination and whimsy are not being given enough shrift, if it will. Like they're not being given enough heft in daily life. I think, not just because of AI or anything. I think it is the most wonderful gift we have. It's what it means to be human. I think we are doing ourselves a disservice by not paying enough attention. I 100% think that that is one of the things that I would say would be, please do that. And number two, and this sounds like the kind of thing that I might have said before, is I'd encourage people to tinker more, to produce more. And I mean, I've said this before. I think, including connecting to the last question that you asked me, there's a large amount of learning that is impossible to get by reading. Almost all of the useful learning, in my opinion, which is, I still don't know exactly how or why, but there is a certain process where doing something actually teaches you a lot more than reading something or listening to something. And as a consequence, if I can push people more towards acting on anything, it doesn't even matter what it is, just doing something, I think it would dramatically improve the way that we actually perceive the world and are able to make use of it. I would love to see that happen.
I love both of them. My friend David Ha, who is brilliant at AI and everything else, when I was chatting with him, I said, like, what's the one quality you really like to see in someone you might want to hire? And he said, they have to love tinkering. And
Yeah.
so I just I also I think about that a lot, and I love both of those, obviously. Well, thank you so much for rejoining us. I'm sure we'll have you on again. Just briefly tell people where they can find you online.
I am on strangeloopcanon.com, and I am occasionally on Twitter. You can find me at Christian Rohit.
Perfect. Thank you so much, my friend. Until next time.
My absolute pleasure, Jim. I love doing it as always.